With the details of the Cybertruck pricing, range, and features now released, many of the Tesla fans, and particularly the institutional investors, were disappointed with the pricing. The big question is, though, was Tesla forced to have higher prices due to higher costs of manufacturing, or did they price it as many of us believe simply due to demand outstripping supply for this coming year? Today, we'll be speaking with a supply chain expert who can review the potential margins that he expects the Cybertruck will have, from savings like automation, the 4680 batteries, the new 48-volt architecture, not needing paint, and a manufacturing-first approach, among others. We've got Jeff Lutz joining us. He's an ex-supply chain executive. He's run manufacturing firms in the past. He's currently running his own consulting firm. Welcome, Jeff.
Yeah, great to be with you, Herbert.
So these two topics are exactly the kind of topics I've been wanting to get you to come on to tell the audience, because you're really one of the people that have tremendous experience on this. One is, did they price it correctly? Why did they price it high? And two, of course, is, your bread and butter, supply chain, cost of goods, the margin. What is our expectations for margin? There's actually a debate that I'm going to share. Some people were saying, they think that the margins are going to be very low because of various reasons. And then you can address if you think that that's correct or not. So we've got James Catt first starts off this conversation, and just his own opinion. He thinks that Elon was talking up how costly the Cybertruck was to build on the earnings call, but that was just a cover for the higher than promised but perfectly reasonable new prices. Okay, I'm not sure about that. But then he says, I believe the costs are being overstated and they will collapse much faster than Tesla wants to admit. And because Cybertruck volume will be low for a while, this will be massive in financials until some point, and it won't be. That part I agree. Now, you replied, I believe, to him. You said Wall Street and fintech has this completely wrong. People that do product for a living know when demand is unconstrained for a significant period of time, which is what Cybertruck has, and supply is meaningfully less than demand for that same period of time, you increase the price. There are other dynamics such as supply base running at a lowest speed, utilization, and yields to start, therefore highest cost, multi-year commodity inflation like on steel, but I don't want to belabor. So obviously it's just the beginning. It's going to be high cost at the beginning. Certainly they're not making any margins at all. They're losing money per every Cybertruck they're making. That's why they priced it high. But this is a new stat that you just shared that I had no idea. And I bet you the vast majority of people don't even know this. Can you share what we're talking about here?
Yeah. First off, and I'm a stickler. I had a spell correct issue with the word steel, which I know how to spell, obviously. But anyway, what I was trying to show here is I try to go back to around the point, which is the end of 2019, early 2020, when they announced Cybertruck, and what was the price per ton of steel. Remember, these vehicles are very commodity rich in terms of trying to understand, what their cost structure should be, whether it's the battery system, whether it's the exoskeleton, whether it's the frames, whether it's the wiring. So you think of something like steel, which is, a big portion of Cybertruck. The fact that steel's basically, depending on where you look on that curve, when they announced a product, 30 to 50% higher per ton than it was when the product was announced. This is a variable into like, why was the Cybertruck pricing back then? Nobody thought back then that steel would go up, basically 50% over that time frame. So this is what people you'll understand. Like, they think like inflation is coming down. The rate of price increases are coming down, but we've had tremendous commodity inflation over the last couple of years, and this is part of the reason the price is the price of the product. And there's many other reasons as well, but I wanted to just get that point across. The other point to get across is that supply demand dynamic. It just, for some reason, I think it's gone over the heads of some on Wall Street that are kind of like, the price is higher than I thought. Well, if the price is higher than you thought, then it's possible that you weren't factoring in things and you weren't doing some of the homework potentially on the COG side. The other thing is, forget it if you put commodity inflation to the side. At this point in the ramp up of a product, every supplier is running at their lowest speeds, their lowest yields, and therefore their lowest rate of utilization that they will ever have during the lifetime of the Cybertruck. Let's say Cybertruck is going to be a 6 to 10 year type product in the marketplace, you're talking 72 months, 6 years. Over that 72-month time frame, this month here and the last couple of months are the least efficient, lowest velocity, lowest utilization point over that 72-month time period. If you're thinking 10 years, 120 months. So just think of it in that context. And therefore, all those costs, they roll uphill. So in these situations with OEM and supplier, in general, you sign a contract with a supplier to produce a part at a certain cost. And what that supplier will do is that supplier will say, well, they'll look at all these different factors. Like, is Tesla good OEM? If they ask me for this amount of material, do they always take it? Is Tesla somebody that is kind of moving the market forward in volume? They factor all these things in. But one thing they factor in is like, I'm going to have low efficiency in the beginning. I'm going to be super efficient later on. And so what everybody does is it's a race. And what the supplier does is the supplier tries to run ahead of their ramp curve and pricing curve they've given to Tesla. And the faster they run ahead of that pricing curve and that efficiency curve that they've given to Tesla, the more money they make. So that's what everybody's in the mode of right now. But the reality is it's physics. It's just startup at this point, and you're at the lowest point of efficiency that you'll probably ever be at the life cycle of program. That's driving the price structure at this point. And one concept that I would love the viewers to just understand, the concept of, this is in pricing and COGS, launch, lifetime, and terminal. The two most important are launch and lifetime. Launch COGS or launch pricing. Launch COGS will be the highest that they'll ever be in the history of that product line. Launch pricing may be the highest that will ever be in its lifetime. It usually is the highest that it will ever be in its lifetime. And then what product managers do and what people that are running the financials for the business case of the company and the project do is they look at lifetime financials. So launch versus lifetime. So what's going to be my average takedown on COGS? What do I think I'm going to do from an event-driven perspective on COGS? And then from a pricing perspective, where does this thing need to go down its price curve for me to hit the volume targets I have for the product? So all those things are modulated together to give the lifetime view of the product. So there's launch COGS and pricing, there's lifetime COGS and pricing. And terminal is basically like what you think, like what's the best you think you can get it to ever, and where do you think you'll end of life the product. End of life means you draw down the supply chain, you draw down the inventory and channel, and you're usually getting it ready for the next product to replace it.
Okay, thank you for that. So what we're going to do now is show you the prices of Cybertruck against gas trucks, against the Rivian and other electric trucks, and just compare it. And what we're going to find out is the prices for the Cybertruck are actually very competitive today. And the disappointment that us Tesla fans had was just based on what they announced in the 4 years ago. You just showed one of the reasons why it was higher, but in fact is very competitive today. Let's go take a look at that. So this is Cybertruck versus the Ford F-150 Raptor, which is a gas car. And you can see that the Ford F-150 starts at 109,000. It's 700 horsepower, 3.6 seconds. Ground clearance is only 13.1. No steer by wire. Here's the length. Here's the payload. And if you want to compare it to the Cyber Beast, so the Cyber Beast is cheaper. It's much higher horsepower, much faster. By far, the 0-60, the ground clearance is crazy and it's flat. This probably has a differential to steer by wire and so forth. And the maximum tow is more, the payload is more. So compared to the F-150, it's fantastic. Chris Hilbert did this comparison against the Rivian R1T. And basically, again, if this is the Rivian dual motor against the all-wheel drive, then you get the quad motor against the Cyber Beast. And while it looks like that the base prices are cheaper than the Cybertrucks, but if you add in the tax credit and then you add in extended range and the price for extended range, you'll see that Cybertruck is much further extended range, much lower price, or the same price by that point. And then all these benefits compared to the Rivian, it compares very favorably against the Rivian. Bed length specifically is one of the big ones.
Yeah.
And then
Let me give one takeaway on all these charts that nobody's talking about and the Wall Street's not talking about. I think it's important for the viewers. And there should be a line on there that says time in market. And I believe the Ford F-150 is approaching 2 years from mass production. The Rivian is in that range as well, and Tesla's at 0. And so you're looking at time equals 0 for Tesla pricing, and you're looking at time equal 20 to 24 months for the competitive pricing. They've had 20 to 24 months to ramp their supply chain, to put cost reduction, event-driven cost reductions in, and that's still where their pricing is. You're comparing Tesla T equals 0 pricing to Tesla, and not saying you, Herbert, but these charts and Wall Street are doing that, and that's actually not a correct. The way to look at it, if you look forward, if you were to put Tesla at time equal 2 years, Tesla's number one. They're going to have multiples of the scale of these projects, these other competitive, and they have a history of taking their cost structure down faster because they have the scale and because they have this rapid pace of introducing changes into the line. So I think it's an important takeaway of Tesla's at time equals 0, and they're at time equal 20, 24 months in market.
That's a big point. Thank you so much, Jeff. That's exactly correct. So first of all, I'm going to take a lot of these slides that you're seeing here. I know there's a lot of info. I will post it on my website at herbertong.com. Check it out from there. But thank you to Chris Hilbert and Zillings. You'll see his charts as well. But thank you for putting together this information that we just walked through. This is Zill _LLIX. This is fantastic. Follow this account. So this one is just an amazing amount of work. You'll see here compared the Cybertruck all-wheel drive against the Rivian R1T all-wheel drive versus the Ford Lightning Lariat extended range battery. And again, I'm gonna post this, so you're gonna have to check out his X account to find this. But generally, you see here that again, the starting prices for the Cybertruck is in line with these other comparative trucks. So why is everybody freaking out about how expensive it is? Of course, they were going to buy it, and so Tesla fans, and so they were upset. But if you take the federal tax credit, it's actually right in line. Then you look at the comparison, it is better. Now, you might say the base range is lower than the others. It's kind of like lower than the Rivian R1T by just 12 miles. But again, if you add in if that matters to you, add in the battery extension, which is an option for you, all of a sudden you get way more than these others, but you have all these other benefits like the.
But you have double. But you have you may have double or triple the charge rate, and then you have an infinitely amount more of charging plugs that you can go to for Tesla. And I think that's the whole charging, the whole battery size and charging. The whole thing has changed even for Tesla. I think Tesla in 2017 and 2019, when they announced a lot of these futuristic projects, the Semi, the Roadster, and the Cybertruck, they had this feeling of like, yeah, these things, the batteries are going to be super efficient. We're going to do our own 4680 cell, and we're going to be able to put 500-600 miles of range and just blow away the range anxiety issue. And what's happened is the 4680, from an efficiency perspective, I mean, let's be very open. It's not where it's projected where it needs to be. But what Tesla's done in the background is they worked their ass off on the charging infrastructure side. They've expanded this charging infrastructure, and then the engineering team has expanded and improved the charge rate of the products. You have faster charging, you have more charging plugs, and from a sustainability perspective, putting all that hunks of nickel and copper and all those battery cells into each client or the car, call it the subscriber or client side, and putting all that mass out and that energy out versus leaving that back and putting it into the supercharging network, from a sustainability perspective, that's a much better thing. And we can probably have a whole episode, Herbert, on like what's the sweet spot for battery. And I think there's not one answer, number one, but there's also, it's a multivariant problem with again, the number of charging plugs and the charge rate of the product. So when you put these charts up and I hear analysts talking about them, I don't believe they're doing proper comps. Like if you were to take Tesla's investment for what they did in their charging network and divide it by the number of cars in the network, you would realize why Tesla has to price things where they do. But I go back to the pricing that's on these things is very competitive. I think Tesla could have been even higher in terms of their launch pricing and still been okay and still have sold every truck they need to until they get the supply demand equilibrium.
Okay. This next part is the one I've really been looking forward to. This is the part that only you, one of the few people that can actually answer this correctly. What is the margins for Cybertruck now and the future? There's a debate that's going on, so I'd love to get your feedback on this, the cost of goods and so forth. So this is Warren Redlich. I was on a space with him and we had this discussion. And his point was that, he's looking at the Cybertruck and he said, it weighs 28% more than the Model X long range. That's almost 30% more than the long range. And he goes, wouldn't that roughly translate to 28% higher cost of goods? Just, using the weight as a proxy for cost. Cybertruck certainly has many manufacturing efficiencies compared to X, but that 28% is a big number to overcome. And so he asked you, what do you think? Your answer is cost is not usually one-to-one versus mass in a complex multi-component 10,000 part system in the case of an EV. However, there is certainly some correlation. Because of this, yes, there is some correlation as it drives more power consumption. And then he asked, do you have any thoughts on likely cost of goods? So, I was saying to him in my space with him that, we know that the Cybertruck has no paint, which is significant savings. It's using the castings, using the 46A batteries, structural batteries. We'll discuss further the 48-volt architecture, which is a less wearing, less weight. There's no stamping because it was designed for manufacturing first. So my assumption was they built it this way because they thought about how to make it cheaper in scale in the future. But then, of course, there are increasing features. It's technology they've added to it. New air suspension, special tires, larger glass. So, can you walk me through what your thinking is for the margins for Tesla, or the Cybertruck and the cost of goods, and then what will happen in the future?
Yeah, it's an area under the curve. The way to visualize it is this area under the curve, and also go back to the launch versus lifetime pricing. So at this stage of a program, like I said, every supplier is running at their lowest rate of utilization they'll ever see, their lowest speeds, their lowest output, their lowest yields, and therefore they'll be at their highest cost structure. And they'll factor that in when they give pricing to Tesla, and Tesla will negotiate with them back and forth and so forth. And then they'll have their lifetime performance in terms of utilization, yield, so forth, and then their lifetime cost view. So right now at this point in the program, the COGS are going to be as high as they'll ever be. And, it'll be from a gross margin perspective, it'll be, we're into the building the hundreds and thousands of something that may be many millions of units over its lifetime. So in this very short, if you were to look at this over the lifespan, and this was via a bar of like total volume in millions of units, we're going to build this many units at a very high COGS structure. But then when you take that and divide it out over its lifetime, it's going to be minuscule. It's going to be nothing. And that's why we have to think about lifetime gross margins on the product. And then there's another factor that we're not talking about here, which are all the accessories that Tesla has ready at the time of launch. And in other businesses that I've been in, high-tech businesses, when your accessory lines, you're usually designing them to be double and triple the gross margins of the base product, because these are things that they may not have 100%, like the product has 100% attach rate. Like somebody buys your product, they've attached to your product. The accessories attach rate is much, much lower. So there'll be lower volume, but when there's a need or desire, people will spend the money for those accessories, and they'll probably pay more than they probably should for that accessory. So the accessories business is going to be super high gross margin. In each one of those things, Warren is a great thinker on these topics, and he does a really good job kind of like logically thinking through things. When you think of COGS, you have to think about, like when you saw the nose of like no paint shop, that you have to think about like what's being replaced. Is it truly a delete Or is there something that's on the other side of it? Like I saw no stampings but then you have this air bending process that Tesla has to introduce. And then are there defects associated with that? And so every action, every process, if it was truly deleted, that's what you want. That's what Tesla goes for. They go for the true delete, like the door handle, for example. That's a true delete. Now it was replaced. There's a switch and a door handle, and the switch is still in the car, and there's a cutout. So Tesla looks at every single one of these operations. They go for the true delete, the true removal. Like for example, no clutches on the two rear motors, for example. And then there's things that are modified, but then better in a lower cost structure. So for example, the 48 volt, like there's a communication architecture right now that the entire auto industry is using, 12 volt, and they're using all this wiring all over the place, and there's harnesses going everywhere, and that works, and that's stable, and there's a supply chain for that, and it's fully ramped up. What Tesla is doing, Tesla's approach is actually Ethernet based, where you've got power and you've got data going over the exact same connection, and you need it's higher voltage, less current, so the gauge of the wire can be much thinner, less mass of copper, and less total mass of that. So what in the case of the 48 volt system, the way to think of that is Tesla's got a supply base that's going to be running at low velocities in the beginning, that they've got to be ramped up. So it's going to be high COGS, high launch COGS in the beginning, but the lifetime COGS structure of the communication system inside of the car will be better than the lifetime COGS structure, I believe, of the 12 volt system. And that's what you want to be focused on. What is the lifetime COGS over many millions of units? They chose a simpler, more efficient, and they're actually removing raw materials in mass from the vehicle that will never need to be produced over its lifetime, all that copper and so forth. So that's the way to think about COGS. Are there true deletes? Are there true things that are being added that would not need to be in a conventional vehicle? Those are the ways to do the proper comps for COGS. In short, I think it's going to be a bit, it's going to be negative for some period of time as we're in the hundreds and thousands of units. But I believe when they get into the many tens of thousands of units, at some point next year, there's something called break even. This is what companies do. They set a point in the calendar of like, what does my production run rate need to be? What does my sellout rate need to be in distribution for me to get this product to break even? And there's a term in the industry called time to break even, TTBE, and that's one of the things that the CFOs of the world look at, the accounting folks, product managers, and of course the engineering team is the one, and the manufacturing engineering team and supply-based teams are the ones figuring out how to actually get to break even faster. And the way you think about that is you think about that in speed and utilization. And if you can get your suppliers and yield, speed, utilization, yield, if you can get your suppliers to run faster, quicker, like if they can get to their peak run rate faster, if they can utilize more of their fixed assets at a higher percentage, and if they can get yield is how much material comes in and what comes out that is good. If they could start at a higher yield and they can get to their peak yield faster, their COGS structure will come down faster. So what can be commonly done in the industry is taking a component, like let's say it's the, I'll make up a component, the rear bumper on the car. The rear bumper on the car has some sort of molding operation, has a painting operation, and there's cutouts in it and so forth. And all those things are speed, utilization, yield. And what they would try to do is this, they'll be negotiating back and forth with the supplier, and I'll promise this will end in like 30 seconds because I know it's a little wonky. What they're trying to do is they're trying to get that supplier to say, all right, when can you get all your tools up and running, and how quickly can you get your whole supply chain up and running for that bumper and part? And they'll say something like, it's going to take me 16 weeks. And what good, supply-based engineering teams will do, supplier engineering teams will do, is go in and go through that detail. Let's see the tooling schedule. Let's see all the fluff in it. Let's see the yields. What are the real problems? Strip all that out and say, well, no, it really should only take you about 5 weeks to get to that point in time. And that delta from that 5 weeks to 14 to 16 weeks that they were promising is money that they're trying to make. So long story short, and from a cost perspective, it's about speed, utilization, yield, very high COGS in the beginning because we're building a very few amount of cars. But you have to look at the lifetime view of how many vehicles we're going to build over the lifetime of the program. They're going to get all those things running their peak velocity, peak yields. I believe from a lifetime gross margin perspective, and I want to do a proper model on this, but I believe this could be the highest gross margin vehicle that Tesla has in the lineup today.
Thank you. Thank you for saying that. Somebody had to say that, because when I say it, nobody listens. But when you say it, that's exactly what I wanted.
Yeah, and especially when you factor in, Herbert, the whole accessories piece of it, like the Cybertruck product line has every element from what they've done from an engineering perspective, what they've done with the accessories piece of it, and what the product is, and what people in the marketplace they put a value on trucks because they're high mass, they're high utility, and they'll pay money for them. So when you put all those factors together, I think it has the potential to be the highest gross margin product in the land.
Well, the two parts was, you just showed us at the beginning of the show, though, that the price of steel was up. So that has to go down. But two, what you said was that a lot of the work that they did with designing this was pure delete, true delete, and they did that. And then three, the accessories, some people are countering me because they said, well, there's going to be a lot of third party. They're not necessarily going to buy it from Tesla, like the wraps. There's going to be others. And so they were saying, what's your estimate of how many people will actually buy wraps, for example, which is incredibly high margin, right? Like we're talking $6,000, $8,000. The price.
Yeah, I think, those could be 20% or more, maybe 30%.
Okay.
So it could be a high number. Tesla's offering that, and they'll make high margins on that. The other thing is, let me just take 30 seconds on the accessories business. Yeah. There's a value on being qualified or approved by Tesla. So there could be third parties. There could be people popping up from various countries saying, I'm going to make an accessory for Tesla. And I think Tesla could turn this into a very good business, number one, by either making their own accessories or qualifying others, where they get into a revenue license share agreement of saying, all right, you're going to design this, but I'm going to run it. I'm going to qualify it inside of Tesla. So I'm not going to need the engineering resources to do all the design work. I'm not going to have to baby you to ramp it like you're going to do it yourself. But every one of these things you sell, I want to get a share of the revenue if I stamp it that it's approved or qualified by Tesla. I don't know if Tesla's thinking about that, but if they are, there's value in it because there's the Tesla brand, and the Tesla brand is engineering, quality, and technology. And if I was buying an accessory, I would want to know that, did Tesla approve this accessory or not? So there could be the point of third parties, that there could be a revenue share, license share with that.
Okay. And then I want to hammer home.
Maybe Tesla wants to do that.
The 48 volt architecture is a big deal. Let's walk through that very quickly. I'm going to do another show with Tesla Larry Goldberg. He's going to walk us through detail here. But you thought this was important because the 48 volt system is going to make its first appearance in the Cybertruck, and it's massive. So this is a regular car. Every single wire, it's massive, it's heavy, it's thick. They're all crisscrossing each other. Everything that has a button. This is Cybertruck because 48 volt, and it's going to be much less wiring required for it. The Cybertruck guy does a good job explaining this. He says, you know how cars have huge wiring harnesses? That's because each component needs its own set of wires connected to central ECUs in order to function. Every speaker, every switch, every sensor, every actuator, every button. Tesla threw out that entire system. Instead, they're running gigabit Ethernet cabling with a 48 volt power and data CAN bus to every component, all in the same cable. So instead of running one wiring harness to the driver door speaker and another to the driver's door window motor and another to daisy chain them on the same self-contained. Oh, Cybertruck, they can daisy chain them on the same self-contained cable interface. Your computer can connect to your door handle using the same wire that's already been through your speaker, window, ambient lights, and steering wheel. each of those devices listen to the continuous stream of data for command relevant to its operation. So Tesla was able to reduce the total wiring in the Cybertruck by 77%. That's crazy, using half the copper. That's one of the ways that they're going to reduce the weight, they're going to reduce the cost. It's a delete, as you mentioned earlier. Any last comments here?
Yeah, and there's a reason. There's supposedly a manual that Tesla put out and sent to the CEOs of other auto companies of saying how to do this. Why is Tesla doing this? Because Tesla's, Cybertruck's going to be what, 250K, whatever you think the yearly volume is going to be, 500K on a base of 80 million cars built a year. For 48 volt, there's two sides of the equation of 48 volt. One is it's simpler, so its COGS can be lower once it's in mass adoption. But if it's not in mass adoption and it's lower volume, it will be difficult to get the COGS structure of that lower. So you've got this 12 volt architecture that's across 80 million cars basically, and you've got 48 volt that's across a few 100,000 cars. So Tesla wants that supply base ramped up. They want, by the way, if Tesla's got a lot of IP and they've worked with a lot of these suppliers to ramp this stuff up, I'm assuming they'll be able to license some of that out too with some of these suppliers. That's not the forethought. The forethought for Tesla is if others pick up 48 volt, number one, their cars will be lighter. They'll need less, they'll need less batteries. They'll be more sustainable. They'll be cheaper to build. But that supply base needs to get to real mass scale. And if it's only a few 100,000 a year, that will be, so that's the thing. Going to 48 volt for Tesla, a bunch of deletes from a COGS perspective, but from a supply chain scale perspective, there's going to be some drag on the price of those components if they're not running at scale because others haven't adopted it yet.
All right. Thank you, Jeff. Another great show. So Jeff and I did the show that you need to watch if you haven't already previously, where we talked about the factory automation. Today, we talked about pricing and cost of goods, which is his bread and butter, and you just learned a ton from him. Follow him on X at the Jeff Lutz. I'm going to post the charts you saw today on my website at herbertong.com. Thanks, everybody. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.